Hello, welcome viewers. Welcome to again the session for the numerical techniques that we studied in the previous lecture about the interpolation. We shall continue and summarize this topic now. Just in the previous lecture, what we discussed, how to find the interpolation. Now, in the interpolation, the problem is that when it is asked fit the polynomial for the particular method. Let us discuss this using an example for the Newton's interpolation. Let us see an example. Find the Newton's backward difference. Newton's backward difference interpolating polynomial. Now, if such is the case, then it is definite the value of the interpolation point is not provided in the problem. That problem will convert into a polynomial. Then how we calculate? If we follow the same procedure that we did in the previous lecture, that will create a numerical or calculation problems. For more simplification, we just consider a data. Therefore, this say x, y, it is 1, 2, 3, 4, 5, 6, and 19, 40, 79, 142 and 235. It is the data provided for the interpolation and the requirement is written. The method will be written either Newton's backward difference or Newton's forward difference or by Lagrange's method. Lagrange's method can be solved directly, but the problem is in the Newton's backward and the Newton's forward methods. Then how we will deal them? First of all, the construction of the difference table is same. Let us say delta 1 y, it is 19 minus 10, 9, it is 21, 39, 63, 93. Inverse delta 2y is equal to 12, 18, 24, 30. Delta 3y, that is equal to 6, 6, 6. And delta 4y, that is equal to 0, 0. That is the case, we terminate our process for the difference table when there are all zeros in a column or until we reach at last a single value. The procedure is somehow same. Say here we know P is equal to x minus x0 by h. And here we see the formula for the backward interpolation was y0 plus P times delta 1 y0 plus P into P plus 1 divided by 2 factorial delta 2 y0 plus P into P plus 1 into P plus 2 divided by 3 factorial into delta 3y and so on. Here problem is that we cannot find out P because x is not provided. X is the point of interpolation. It is not provided, so we cannot calculate P. Even the condition of the P, which was between -1 and 0, it cannot be checked in this case. Again problem is this x, that is a point of interpolation. Then what we do, we start from the last value because it is the backward interpolation. If it were forward, then we would have selected the first row. If we select this, these numbers will be selected in this way. The trail is from below to above, like this. Here is 0. But it is x0 and it is y0. What we do, we calculate the p. P is equal to x minus x0 divided by h, that is equal to x minus x0 is 6 divided by h. H is the height of the interval, 1, 2, 3, 4. The difference is only 1, it means height of the interval is 1, that is equal to x minus 6. It means it is a simple method to calculate this formula by interchanging p with x minus 6, because p we cannot calculate, then why should we interfere with the p, and we remove the p by using its value x minus 6, because we know x0 and h, and x will continue its nature in this way and we will reach up to a polynomial. In this way, say we change this formula now, that is f of x is equal to y0 plus, we change p with x minus 6 into delta 1 y0 plus x minus 6 into x minus 6 plus 1 divided by 2 into delta 2 y0 plus, for this, x minus 6 into x minus 6 plus 1, x minus 6 plus 2 divided by 6 plus delta 3 y0. Now we have to move up to delta 3. We don't need delta 4. Plus so on. What we have done? We have changed the p from the standard formula into x. No. Here we can see the p is nowhere existing. Now we put the values, that is, say f of x is equal to, what is y0? That is 235. We are starting our trail from the last value of the data, moving upward in the trajectory, If it is forward, then we will start with the first values, first pair, moving downward in the trajectory. That is 235 plus x minus 6 into delta 1, that is 93, plus x minus 6 into x minus 5 divided by 2 into inverse delta 2, that is 30, plus x minus 6 into x minus 5, x minus 4 divided by 6 into delta 3 y0, delta 3, that is 6 into 6. So on, we need not write the further values because next value in the difference table are 0. Now we can calculate, it is a simple algebra for the polynomial. Here that is f of x is equal to 235 plus 93x minus 93 into 6 minus 558 plus, we can divide it, 15, 6 with 6, x minus 6 into x minus 5, that is x square minus 11x plus 30 into 15 plus, multiply both brackets, first of all x minus 11x plus 30 into x minus 4, that's equal to 235 minus 558 minus 323 plus 93x plus 15x square minus 15 into 11, that is equal to 165x plus 15 into 30, 450 plus x square minus 11x square plus 30x minus 4x minus 44x minus 120. That's equal to x square, it is 16x square, then 93x minus 165x plus 30x minus 44x, that is equal to minus 86x, and 4x square, it is 15x square, 16x square minus 11x square, that is equal to 5x square. Next terms, it is 450 minus 323, that's equal to plus 127 is equal to 0. So again check, it's 93 minus 165 plus 30 minus 4 minus 44 is equal to, it's minus 90x. That is a polynomial which we can construct in case of the Newton's backward or the forward difference methods when the point of interpolation is not given. But in the Lagrange's method, it is very simple. If we don't have any x, we directly solve the system because there is no involvement of the p. But the only one point is, in this case, we cannot decide the value of the p. So always when it is backward, we start with the lowest value. When it is forward, we start with the uppermost values.